it's not overloaded, but it keeps tripping. But the ammeter can't read that low. I just take a piece of the wire, I wind it 10 times and tape it up. I start the motor up, all my measurements are measured there. Okay, so we also can use circuit breakers in panels instead of fuses. And the nice thing about a circuit breaker is that it's still there. After it's tripped, you can go reset it. The downside to it is that the protection's not nearly as good. In the case of like VFDs, where the power handling stuff is solid state, unless you have really fast fuses, you can't protect that from a surge with a breaker. Breaker just can't do it. It's mechanical. And a little interesting thing, my aunt worked for a breaker company when she was younger, and her job was testing circuit breakers to make sure they would trip. You want to know how she did it? She held the breaker in her hand and she went on her palm. And if the mechanism was good, it would trip. No electrical test at all for home breakers, but that was her job, testing circuit breakers. They come down a line and smack, and if it trips. So circuit breakers work. There are actually two kinds of circuit breakers, and more than two, but the basic ones are magnetic and thermal. Magnetic circuit breakers, they only trip with a very high current, and they trip as quick as possible. Thermal breakers allow you to draw a lot more current for a short period of time so that you can get a motor up to speed and that kind of thing. The ones in your home are generally magnetic thermal combined. I suspect though that years ago that some brands were only thermal because they were almost impossible to trip with a short circuit. You couldn't get them to trip, and I suspect they were just thermal. So they also have breakers, which we will see in panels, called MCPs, motor circuit protectors. What's the difference? Well, the motor circuit protector is a circuit breaker that only has the magnetic trip. And the purpose of that magnetic trip is to clear a short circuit, not the motor load. And the reason that they did this is they saved the cost of the thermal protection within the motor, within the breaker, and they instead put an overload block on the starter. And nowadays they are all selectable. You have a range of settings. The downside to the range of settings was that you often found motors burned out because somebody just turned up the setting on the overload to get the motor to keep running. In the old days before that, all the thermals were done with what they called a heater. And the heater was a little short coil of wire, a very heavy wire actually, and it surrounded a round pin, what looked like a pin. But what the pin was is there was a rod inside, and it was filled with solder. And what would happen is in thermal, the wire would heat up and melt the solder, and this little rod would turn and trip the breaker. And that's how the thermals work. So when you got these, when you put in a motor, you always had to select the heaters, one for each phase, and you had to select the ones that were appropriate for the motor's running current, plus a little. And so once you put those in, there was no chance of anybody inadvertently tampering with it and turning the dial up to make it work. And they were really reliable. That was a good system. But now it's just so much easier to turn the dial and to match the motor thing. So as long as everybody remembers to do it. Mm-hmm. Often you just see them turned all the way up, and it's... So, I'll bring up one more thing about this. So, when you're checking motors, primarily motors that are fractional horsepower, less than 1 horsepower, I would say up to maybe 3 or 4. typical thing for checking the load on a motor is a clamp-on ammeter. And what a lot of people don't realize is that how the clamp-on ammeter actually works. It detects the magnetic field generated by a wire when you clamp it on. The problem with modern ones that are digital is that the scaling is done by electronics inside the meter. And you will see on the meter there will be some number like plus minus 3 FLA. Plus or minus 3 FLA. What does that mean? That means that if you have a typical clamp-on now that's rated at 200 amps, it can only read accurately to plus or minus 3% of the full load amps. Well, that's plus 6 to minus 6. That's a big range, especially when you're dealing with a motor that only draws 2 amps. So I have been on so many trouble calls where the customer says, we checked it with an amp meter, it's not overloaded, but it keeps tripping. Yeah, how you checking? Oh, we clamped on the amp meter. Yeah, but the amp meter can't read that low. So if you ever work on a panel and you see this on one of the motor leads or all the motor leads, you might be looking at something I did. Because every time I install small motors, I put a 10-turn coil in the wire. I just take a piece of the wire, I wind it 10 times and tape it up and put that in case in the thing. So then when I start the motor up for initial testing, all my measurements are measured there. Right? I did an airplane flight to Buffalo because the electrician said that the pump wasn't overloaded. There's something else wrong. It's a plumbing problem. So I flew up there. I wound a coil like this and I put it on the motor and said, yeah, motor's overloaded. Closed the valve on the plumbing till the current came down where the motor was supposed to be. And I went home. Expensive trouble call. But that's the secret. My dad taught me this trick.
So what's actually happening when you coil the wire up?
It multiplied the current by 10 times. That's why I use a 10-time coil.
So it puts it within the range of your accuracy of your meter.
Right, because now the meter, instead of reading 2 amps, reads 20. And you know, I know it's 2.00.
Yeah.
So that's...
So you have to divide your meter reading by 10.
Yeah.
And then you know what's really happening.
Yeah.
Yeah.
Yeah. So the motor I was talking about, they're telling me it's drawing 1.9 amps. I put the 10-turn coil on it, it's drawing 2.8.
Oh.
Well, it was a 1.9 amp motor. 2.8 was a big overload.
Yeah.
Right? So it's a common little trick. So, but like I said, I tend to do this everywhere as I have small motors, due to the fact that there's no good way to measure them with. Now, there are clamp-on ammeters that have multiple ranges and can do that, but the digitals have become so popular that this became a huge problem because everybody's using this meter that's 200 amps and it doesn't have a range selector or anything else. Mm-hmm. So that's a good little trick.